Layer concept. We have already discussed transport layer services, multiplexing and demultiplexing concept, UDP concept, that is user datagram protocol. Then we discussed all the RDT concepts. So RDT stands for reliable data transfer. So we have already seen several versions: RDT 1.0, 2.0, 2.1, 2.2 and 3.0. So all these services we have seen. These are all the services about of TCP. Now let's move on to the next concept of TCP, that is connection oriented transport. So we have here various services provided by TCP which has to be discussed, out of which I'll be discussing with the segment structure. I hope all the previous concepts are clear. So here we are concentrating only on TCP, which is connection oriented transport protocol. So let's see the segment structure. Before we start with the segment structure, let's just have an overview of TCP. As you all know, TCP is Transmission Control Protocol. It is providing the handshaking principle. Handshaking is supported by TCP. So what is the meaning of handshaking? Handshaking is the one wherein you have a sender and also you have a receiver. Sender will be sending the request first and the receiver will send back the acknowledgement for the request that is made by sender. This acknowledgement is sent only when the receiver is ready to set up the connection between the sender and itself. So once the receiver sends the acknowledgement, that means the receiver is ready and now the first stage of handshaking is completed. And we call this first stage of handshaking as connection establishment stage. It is connection establishment stage. Once this is done, next our sender is ready to send the data or the message to the receiver. So here the sender is sending data. You call it as data transfer, which begins at this stage. Now the receiver will send back again an acknowledgement which indicates that it is the receiver has received the data successfully. So you can call this final acknowledgement as a receipt for the acceptance of data. So once this is done, you can call now this as the second stage of handshaking. So you call here, this is the first way of handshaking where the request is sent. Then the second way of handshaking where the receiver is sending an acknowledgement, and along third way of handshaking, I'll just number it: first way, second way, and finally it is the third way of handshaking where the actual data transfer begins. So you can also call this handshaking principle as three-way handshaking, and this three-way handshaking is supported only at TCP, or it is supported only by TCP. Okay, so we have here one of the important feature of TCP, that is point-to-point link. You can notice here it is just the point-to-point link between one sender and one receiver. So this is here only one sender dealing with a particular receiver. Multiple senders are not communicating with the single receiver simultaneously. So here only one sender is communicating with the particular receiver. Once the sender's transmission completes, the connection between sender and receiver will be broken down. So once the connection breaks up between this sender 1 and the receiver, you can now say that the receiver is free to accept the request from the next sender, sender 2. So sender 2 can communicate with receiver only after the communication between our sender 1 is broken up with the receiver R1. So here two senders cannot simultaneously interact with the same receiver. Note down. So we can call this as point-to-point communication. The next feature is reliable in order. So what is the meaning of reliable and in order service? Reliable is, as we have already discussed about RDT concepts, it is the one which maintains reliable data transfer between sender and receiver. So TCP is responsible for reliability or reliable data transfer. Why? Because here TCP provides sequence number concept. So sequence number is the one which is given to every byte that is transferred between sender and receiver. So the data whatever is sent here from the sender to receiver is sent in the form of bytes. So every such byte transferred will be obtaining a sequence number, unique sequence number. And because of this sequence number, you can say always there is in order delivery between sender and receiver. So apart from sequence number, our sender also has the concept of sending only limited number of packets. So the limited number of packets are sent through sliding window protocol or go back in protocol, or also you can have one more selective repeat protocol where certain number of packets are sent through sliding window. So you can say here there is flow control between the sender and receiver. Also here we have the concept of checksum added. So the checksum what we have is the one which always deals with the data corruption. So checksum is the one service provided by TCP to deal with the corrupted data. Then we have the sequence number to ensure in order delivery. Then we have the sliding window concept wherein the flow control is managed between sender and receiver. Apart from that, also there is a concept of acknowledgement where the receiver is acknowledging the receipt of the data. So acknowledgement also is sent, maybe it is positive or negative. So apart from this service, there is also one more important service provided by TCP, that is timer mechanism. So timer is the one which is started at the sender side where the packet once it is transferred, for that particular packet the timer is started. So once the packet's acknowledgement is received, once the acknowledgement is received for that particular packet, the timer may be stopped at the sender side. Or if within the timeout period the acknowledgement is not received, you can say that the data or the packet might not have received by the receiver. In that case, the sender will have to retransmit the data. So all these are the services provided by TCP. So we also have something called the full duplex. Full duplex is the one where the data is flowing in both the directions. So you can just notice here Our sender is sending the data, at the same time receiver also, after receiving the data, he sends back the acknowledgement. So the data is sent not only from one direction, it is also received from the other direction. So you call this as bidirectional data flow. And the one more point that you have to notice is the data that is transmitted here along third way, where the data transfer begins, the data is transmitted in the form of segments. So the segments here, instead of calling that as data transferred between sender and receiver here, it is through the TCP connection segments getting transferred. So each segment, you can call it as a data, or you can also call this acknowledgement also as a segment that is received from the receiver at the sender side. So here data is transferred in the form of segments, and there is a limit for the size of the data that is getting exchanged. I cannot send a segment whose size is very large, more than the maximum allowed size. So there is a limitation for the segment size. You have uh, the segment which should be within the limitations. The size of the segment should be within this limitation. You call it as maximum segment size. So next again we have the service of handshaking here, and also we have the service of flow control. You have the concept, or you have the service called pipeline, where multiple packets are transferred through sliding window concept. Okay, so this is the overview of TCP. Let's now concentrate on TCP segment structure. You can just go through this segment. You can also call this as the data segment that is exchanged or that is transferred from the sender to the receiver. You can call this as the segment structure of the data that is transferred from the segment to receiver. Or you can also call this as a segment structure of the acknowledgement packet or the acknowledgement segment that is received from receiver back to the sender. The same structure here is shared for both acknowledgement segment as well as for the data segment. You can notice here the entire segment size is of 32 bits. You can call here, you can just notice here there are multiple fields within the segment. So to begin with, we have the port number. When I say port number, it indicates both the source port number and the destination port number. So in this case, suppose if the source or the sender is sending the data to receiver, in that case, sender becomes the source and receiver becomes the destination. So each system, or here the sender has something called as the socket via which the data is transferred. So every such socket here created at the sender or every such socket that is created at the receiver has a unique port number. So that port number, that is source port number or sender port number, is added within the data segment that is transferred from sender to receiver. Similarly, the destination port number is also added inside the segment in order to know to which socket this particular segment should be delivered. So 16-bit source port number and the 16-bit destination port number is included as a part of the segment transferred from the sender to receiver. The next field is the sequence number field. So the sequence number, as we all know, it is the unique number that is added to the data segment, to each segment, or you can call within each segment, you actually transfer multiple bytes. So each such byte within each segment is going to get a sequence number. So every byte that is transmitted from sender to receiver will have a sequence number which is of 32 bits. And the next one we have the acknowledgement number. See, we cannot have the acknowledgement number for the data transmitted from sender to receiver. Instead, we will have the acknowledgement number for receiver sending the acknowledgement back to the sender. Like how we had sequence number for the data, we have similarly the acknowledgement number for acknowledgement segment. Next, we have the field wherein the header length is mentioned. So every segment, as you all know, has something called as the header, which is attached to the payload section. You can see here this top position, you call it as header, and this below position you can call it as payload. The actual message that is transferred from sender to receiver, or the actual content, is inserted inside the payload section. The above section is our header section, which includes address, which is port number. Next we have sequence number and the acknowledgement number, followed by we have the length of the header, which is mentioned in bytes. Next we have few fields here. These are nothing but the flag fields. Every flag is of size 1 bit. You can see here the first flag is urgent data. U stands for urgent data. Suppose the sender is sending an urgent data, confidential or urgent data. In that case, you have now here third field, third flag, which indicates its P. Here P refers to push. In the sense, sender, if it marks U flag or if it sets U flag, that means the data is urgent data and the data should be immediately pushed from the transport layer at the sender side. It should be immediately pushed. At the same time, here after receiving the data at the receiver, the data, since it is urgent, it should be immediately pushed to the above application layer. So because of this pushing, immediate pushing, the data will be quickly transferred between the sender and receiver. See, you can see here the next field is the flag is A, which indicates it is the acknowledgement flag. If it is set, it indicates that this entire segment is acknowledgement segment. Next flag you have fourth flag, that is R, indicates it's the reset. It's all about the connection between sender and receiver. If the connection has to be reset, then in that case you use reset, or you can also call it as the connection setup. So you call it is not, it is not reset. So you call it as the connection setup flag. So it is something like once this flag is set, that means the connection, you can call it as the first stage of handshaking where the connection establishment is done. This next flag is S, indicates that it is the synchronization between the sender and receiver. So this is a flag which indicates the synchronization. The last flag is F, that is the finish flag, which indicates the connection should be broken down between sender and receiver. You can see here the next field we have in the segment, that is receive window, which is very much important for the sender to control the flow, data flow between the sender and receiver. How the data flow can be controlled? If the sender is sending 10 segments, the receiver also should be ready to accept all 10 segments. Suppose if the receiver is not ready to accept all 10 segments, in that case most of the segments what the sender has sent will be lost in the network. That is why the sender should be knowing well in advance about the number of segments that the receiver can expect. So if the sender comes to know well in advance about the number of segments that the receiver can accept, in that case sender can control the flow and send only required amount of segments to the receiver. So that is done through receive window concept. So receive window is the one where the receiver will disclose about its capacity to accept. That capacity is indicated as its window size. That receiver window size will be notified to the sender, where the sender will come to know about the number of packets that the receiver can accept. So once it is revealed, the sender will control the flow by sending only those number of required packets to receiver. So you can see the receive window over here. Next we have checksum, that is the sender, when he sends the data, he adds checksum along with the data and sends to the receiver in order to deal with the corrupted data. Next we have urgent data pointer, which indicates that the data is an urgent one. So next is optional field, variable length. So this forms the complete header part of our segment. So next we have the payload section where the actual message is inserted. You can note here the entire segment, the structure of the segment is same for both acknowledgement and the data that is transferred between sender and receiver.